Well, hello guys, I'm Sebadon. I'm currently dressed to slay 3D printings. So you're kind of watching a pre-introduction to the video that you're going to watch. Uh, know that the video it's all over the place. I'm I'm doing my best to explain everything I know about 3D printing because many of the people that will see this video will be the first time that they get into contact with a 3D printer. So I'm trying to compress as much knowledge as I can to solve issues that I know that they will have, not only as a first timer, but also for seasoned 3D printers. I have like 6, 7 years in 6, 7 years under my belt in 3D printing, and I'm still learning things. In fact, I was going to release this video earlier as part of a series of videos that I'm releasing for the release of our new 3D printed action figure that we have released the file at Planetary.toys. This action figure has been tuned to be printed with TOF74 B2, but it can also be printed with other resins. But for us, TOF72 out of the top 74 version 2 out of the bottle is kind of the best option for people, and then you can try your own mixtures. Why I didn't release this video earlier, there was an issue. I was getting all the files to print, not perfectly, but I was like 95% sure that they were printing, not the files themselves, but the printers printing consistently, and suddenly nothing worked anymore. And I couldn't believe it because I spent like 2 hours talking about how things should be done or why things should be done in some way, and I was preaching to the choir in some sense, and suddenly nothing worked for me, and I couldn't understand why, because I was doing everything I was supposed to. In the end, I fixed it. I studied a lot this past week. I tested a lot, and I finally found a way to get 100% successful print on big machines, which is not an easy feat. I have seen people have crazy problems with them, and being honest, it's not easy. I have had a lot of smaller machines, and they have been a breeze to work with. Of course, they have had their problems, but in comparison to this, I'm thankful though, because if I didn't have these issues, this video would have been incomplete, and people who would have bought those printers wouldn't have had a real solution for their problems. And of course, this problem is not one size fits all. There will be a lot of assessments to make about what is going wrong with the printer, but I have like 5 machines that are big, right? And they are kind of different brand, and half and half, right? I have 3 Saturn 3 Ultra, 1 Saturn 3, and 1 Anycubic M7 Pro. I think so, yeah. And they are all big. They are all the same size. They print the same height, and they are all printing using the same calibration, no, the same settings for printing, and they print beautifully. And they all the machines have calibration problems that I cannot solve because they are from the factory, and they still print beautifully. So there's a silver lining if your printer is not printing well. If you have any issues, stop by at our Facebook group for 3D printing, and I'll be sure to help you out, or the community. I'm trying to build a community around our figures. Hopefully we can, because the idea that we have is that this project is not ours like my wife and I, but ours as a community. So yeah, you will see that the video is long. I'm all over the place, but I explain such good content. If you have any question, let me know. And you will see that the video is mostly recorded, like in a top-down view. I don't know, all these changes and new knowledge that I have will be at the end of the video before the outro, and well, you will be able to go there and see. Uh, if you are impatient, basically the savior setting that was ruining everything was light off delay, and I'll explain more later in the video. So hopefully you like it. If you're a newbie, take it slow. It's a lot of information. This took me years to understand, and you don't have to understand everything at once just to print. You can just don't watch this video, go ahead and print, and the best way to learn is just to have problems, unfortunately. And the good thing is that the silver lining is that at one point you won't have them and you will just be able to concentrate on 3D printing. And that's where the fun begins, when you don't have to worry about issues anymore. So with that said, hopefully you enjoyed the video, and see you at the end. Lastly, before this video starts, I just wanted to show you a bit of my room. Know that it's messy and everything is, all the walls are splattered with resin, so I'm sorry about that. So here you can see the three Saturn Ultra. There's the Saturn normal, the Saturn 3 normal, then a cubic one, and I have two working Elegoo Mars Ultra, I think, and then I have like a cemetery here of printers, and well, there are two underneath. So if you're a hobbyist and you will start printing, be sure to wrap everything up like this with a plastic, because 3D printing is messy, and I have seen people that only have one machine and it works for them. I need workhorses and I need continuous printing. So hopefully this video worked for us. I'll do a tour and explain my process in another video. So see you. Well, hello guys, I'm Sebadom. I'm a sculptor. I have sculpted landerlings, yeah, for long coconuts, and I am sculpting with my wife sirens of the silver sails. And this video and the following series of videos will be to help new people that haven't delved into 3D printing ever, and I'll try creating some sort of tutorial or troubleshooting to help them not only ease in but jump directly into the pool, into the amazing world of 3D printing. So I have around 6 years of 3D printing, so experience. So I think I have encountered most of the issues that you can find. So for this video specifically, I will be tackling some troubleshootings and some common problems that you may have. So for the experienced 3D printers, that I know that there will be a lot here that they see this video, because I'm sure that they will want to experience producing an action figure themselves, right? To print it themselves. This one was a failed test, but still looks amazing. So if you want to see just the troubleshooting for certain errors, you can go ahead and look into the separated area of the video. I don't know how it's called, but it will be marked after this introduction. This introduction is mostly for newbies, for new people to this craft. So I'll give a brief introduction to 3D printing, and it will be very fast, because what I want you guys to understand is the way I think about 3D printing, and it's pretty conceptual, right? I'm not going to get very technical. So for 3D printing, you get a machine, and the machine basically pumps out resin pieces. There's a lot of types of resin pieces, of resins, but gray standard is the common, is the one that generally people use, and the other one that people may use are the flexible ones. So that's it. For our projects, you will only need flexible, maybe for the belts and for the underbelt here, and the rest is just standard. And I think that they both print with the same settings, so that's no issue. We will get into settings and software in another video, but for now, just stick to the concepts here. So you have small machines, big machines. I don't know why it's not focusing. You have small machines, big machines. They operate similarly, but you will encounter different problems. So we will tackle big machines um, because you will encounter most of the problems there, and it's the ones that we use because we will not only be producing action figures, right here, this figure with all the assets that it comes with, like a lot. It feels Ho Elegu Saturn 3, I think, like the biggest one that it's up to this video's release. Yeah, it fills the whole batch, which is great, right? It's a lot of stuff, but at the same time, you then have to clean all the parts and everything. But you will be able to select what you print. But you can print this that it doesn't look so big, but it has a lot of in parts. But we also will be printing big things like this cannon that my wife painted. Uh, so this was printed vertically, same this. Then you have these barrels here that if you see in comparison with the action figure, remember this was a misprint. It's horrible that it falls on video, but you get the gist of it. So you see that the cannon is huge in comparison to the figure. So in order to print this correctly and that it works properly, the machine, we have to dial in a lot of the settings for it to print 100% of the times great, right? To not get any failure. So printing is a very simple concept. I will draw it because for me it's easier to explain. Um, so you have, doesn't matter, big machine, small machine, doesn't matter. The system is all the same unless the technology changes. You may get SLA, yeah, it reads SLA or resin, right? You will get it but those names, but basically you ask for a resin printer or a FDM printer, plastic printer. This is the plastic. I will have to write better because if not, it won't understand. It won't read. FDM is basically plastic. It extrudes plastic out of a nozzle, and resin it's a different universe, which I will explain now. So for resin, you have several main parts for the printer. So you have the Z axis, yeah, that it's a rod that goes up and down. That's the only thing that it does, and it's just a pole, right? You will see later why I mention it because there are some issues that you may encounter with that. To this pole, you will have the bed connected, right? You will have what we call the bed, the printing bed. That is something like this. It's kind of universal for all the printers. And to this, you will have the supports, right? And then you have our figure, our piece. It can be a ball or different parts like this or this, right? Here you can see something that was straight out of the printer. Here you have some drainage holes. It's all sanded, so you won't see any supports, right? But yeah, basically you have all the supports connected to the piece. Hold it in place. Let's see the focus here. There you go. So the remaining piece here, it's the printing batch. There are a lot of names. Here in my household, we call it bat, right? But it's basically the bathtub for the resin. So with these three things, you can find a lot of issues, right? So basically, this goes up and down, and it submerges the bed into the resin, and underneath this, right, you get a flashlight, yes, of UV light that flashes into a mirror that is kind of like this, and it puts all the light here, right, where the bed would be aligned here. So the resin that we are using, it's photosensible, right? So it means that it cures with UV light. So if this UV light is all the time
flashing into the vat of resin. That, let's mention that the vat of resin has metal walls, and the bottom, yes, here the bottom of the vat is plastic. It's a plastic membrane that lets the translucent light go through. Sorry, translucent light, the UV light go through to cure the pieces. So if this is all the time shining, right, or at certain points, because it will turn on and off. But if it's all the time shining, how does it get the detail to create the shape, right? It should draw something out to create the shape. So basically here, between this light and the bat, we have something that is called an LCD, that you will basically know it because of monitors, gaming screens, or TVs, right? It's an LCD, it's like the technology. But for this thing, before we had color LCDs, but now we have monochrome. Just a bit of information, it's not relevant for this, but the LCD, what it does is it creates a black and white image. It doesn't create it; it takes it from the slicer, right? From the Chitu box, from the leash, which is what converts the 3D geometry in several layers, right? So you will have this model here, which is comprised of several layers, and these layers are controlled by this rod, which goes up and down. So basically, what the printer does is just, okay, this is maybe 2,500 layers, right? So it goes one layer down, cures the first layer, goes up, waits, goes for the second one, second layer, goes up, and like that for the whole thing. So that's the process. So to print something like this, or like this, you're looking between 2 and 11, 12 hours of printing. But just because I'm printing cautiously, I'm printing conservatively. I'm not looking into fast printing, I'm looking into consistent printing. So these are the basics of 3D printing. There is a lot more things that I can explain, but to be honest, if you are a new person to 3D printing, this might have been a lot. But in these type of things, you have to jump into the water, see what sticks, and what doesn't stick, you will fail, and then from that failure you learn. That's the correct attitude to have with this. Believe me, I learned it the hard way. I try to be prepared for stuff, and nothing can prepare you for all the problems that you will have with 3D printing. But believe me, it's super rewarding. I think aside from sculpting, 3D printing, it's my favorite stuff in the world. I don't ever think I will stop 3D printing. Yeah, so this is like the main thing, the super beginner stuff, just how 3D printing works. And then when this finishes, you just remove the bed from the setter rod, which has a connector, and you just scrape it with a metal scraper, which is something like this, and it has a handle. All printers come with everything that you need for post-production except chemicals. You can use water washable resins, which I don't recommend. They are supposedly like they are better for the environment. They are not. It's kind of a scam, and they are more difficult to use. Just stick with normal resins, or even fast curing resins. Those are very good. And use IPA. In my videos, I'll show you how to use it effectively, so it's not as expensive. So hopefully until now, this doesn't lead to confusions. Hopefully you understand everything. Now we're going to jump into the second part before we start talking about troubleshooting. People that know 3D printing, bear with me, we're almost done. And if not, you can go directly to the troubleshooting, which we have several topics to talk about. They will go by very fast because it's just now that you understand this, you will basically be able to understand every concept. And if not, the good thing is that this is YouTube's and you can watch it again. And if not, comment and I'll just answer you. And I need to create a Facebook group for Planetary Dog Toys 3D printing, which is something that we will need if we are going to sell these 3D files of our pirates, right? Of our sirens. My wife just called me out. These aren't pirates. These are sirens of the silver sails, not pirates of the silver sails. So the story of this one is that she was a kind of duchess, like a princess, and she got stranded. Like her ship sank, and she got stranded. So she now carries everything. On top of her, she has like a man's sword, she has like an axe on the back that she straps here to this thing that goes on the shoulder, and then on the belt she has like a knife, right? And she has everything. Like she will be prepared next time if it happens, right? So let's go to the second part. So the second part is my philosophy, right? If I first explained the concept of 3D printing. When you get the 3D printer, everything will make sense because right now these are just doodles on a paper. But when you get the 3D printer, you will be able to recognize the key components of 3D printing on your machine, which are common to every resin printer. So let me read my notes. So I'll explain these concepts, which will later help us understand why we have those issues and how we can solve them and why they are solved that way. So let's dive in. Let's go directly. So how I do calibration? What is calibration, you would ask? The machine here, let's go back to this, the bed, the printing bed, it's on either screws or one screw with a spring, right? Here, let's draw it here. If it's a big machine, it will have like a base like this that connects to the set rod. I'll just call it rod for this video. It has like a thing like this, and then you have the bed, right? On this thing, on this area, right? This area will be separated in two. This will be something like this, like a clamp, and I don't know, it's not focusing. See? There. It will have like a clamp, and this part is the one that hangs, right? Something like this. Well, you get the idea. It hangs on the set rod, and here you have like a circular clamp that you have to twist, and it will apply pressure, and this area here, yes, this area here will stay put, right? It will stay into position. But this clamp here, that it's part of the bed, right? Here you will have all the supports and all that stuff. So it may happen that you hear that my voice is different or that the light is different and the rhythm and the energy that I'm putting out is different. It's because that my camera battery died, so I had to record the other day. Let's see if it's recording. Yes, it's recording. I think so, right? Yes, it says recording. So where we left at. So I was explaining how calibration works. We have the 4 screws here, and why there is 4? Because we have four corners, right, on the bed. And here you will put all the different 3D prints to print, right? In order for calibration to work correctly, you need the 4 corners to be touching the LCD or the surface of the printer, right? This is the printer, to be touching the surface evenly. This would be the set rod. This would be the anatomy of a printer. Here you have the LCD screen for touching and selecting stuff. So here all these 4 corners have to be touching evenly. There are a lot of ways to calibrate, but I am going to show you which are the ones that I found that work best. and I follow one procedure specifically, and I have one variation for that. So for smaller printers, which for example are, you will notice that they have a different system than the screws. There is one specific center, exactly as this one here, but it's spring loaded. Inside you will have a spring, and then a ball here, like a ball joint, metal ball joint, very cool stuff. And here you will have the handle that you can turn. And this thing, this ball, this metal ball, is connected to a peg, and the peg connects to the bed. So as I explained, it's a very different system than this one. And this one only has two screws, one for the side of the ball and one for the front. Technically, they work the same. I think this one is easier to calibrate, and you will see why. Let's start with this one that I have used for Elegu Mars 1, Mars 1, 2. I didn't use the 3, and I have a more Mars 4 now. So these 3 use the same system, the ball system, right? The ball peg with the spring. Very easy. When you have to do the calibration, which I suggest you watch a video, but it's very easy. You just hit home. There is a button in calibration. It hits home. It lowers, right, the set rod, this one. It turns and it brings the bed down. When it reaches the bottom, right, home would be near the rod. There is a laser, right? There is a small laser. Before it was like a small switch that whenever a metal part within the set rod, within the system, touched this, it said stop. That's home. Now this is missing, and it has a kind of laser thing. This goes down, and it says, okay, stop. It hits home. Why it stops there? Because if it goes down, it will break the LCD. So for this thing, what I'm going to say, it will sound like savagery for people, but I tell it, okay, since this is spring loaded, we have to apply the most amount of pressure downwards. So this is evenly distributed. The force against the bed, against the machine, it's evenly distributed. So I tell it to go like first 10 millimeters down, then when I hear that it doesn't go down anymore, 1 millimeter down, and then 0.1 millimeter down. Generally, with the 10 millimeter down is enough, right? The problem that I found with this system is that some machines respond to going down and some don't. For example, I have one that when you tell it to go down, you can feel the metal cranking and the LCD resisting the pressure. For me, it's great because that printer specifically doesn't have any issues for printing. It's great. It has the LCD broken, but it's because like a droplet of resin went underneath a protection that I have, and it cured on top, and it broke the LCD. So it has nothing to do with the calibration system. So this is the system that I have, that I use, right? It goes contrary to the way that companies explain how to do calibration, which is you put a paper that they give you underneath the bed, in between the LCD and the bed, and they tell you, okay, just hit home, go down, and that's it. I don't do that because that way I found a lot of problems. I never do it that way. In fact, whenever I receive the paper that they give you with the machine, I throw it away. And that's it. I throw it away and I use this system. Now, with this thing, the thing keeps the same but changes. So since the surface of the bed is different, that's why we are using 4 screws instead of 2, and we are not using a center. We are using 2 centers and a clamp that basically whenever you screw everything, it's very difficult to uncalibrate it, let's say. The way I do it is to use 2 not strands, but cuts of plastic that I have, translucent plastic, that before we use them for FEP, right, in older machines, but now these new machines use a different FEP. FEP is the plastic that goes on the batt, right? The translucent plastic that lets UV light go through, UV. This black plastic down here is the FEP, right? And now it's called different. It's like a different letters because it's a different plastic. So I have those strips, and what I do is you will have the bed seen from the top like this. That goes down. Here is the connection to the SETA rod that goes up and down. And I would put the strips of plastic like this. Right? So I put them like this. Why? Because this way, whenever it goes down, I can move first this side, then this side, then this side, then this side. In order to have the printer calibrated, you have to apply some force, not much, but not any point of this has to move. If that happens, the print, if it doesn't move, it's perfectly calibrated. What I found is that either the thing, there is one corner that is not properly pressed, or whenever you turn the screws, the thing decalibrates, right? So the way that I found to ignore this, to ignore the issues that we could find here, is to do this. Yeah, what we did in the previous machines. But there's a catch, because you can't press 10 millimeters, 1 millimeter, or 0.1 millimeter. Why? Because the machine doesn't let you. And that's okay. But I found a manual, like a thing that I can do to make it happen differently. So what I do is, we will see the SETA rod connector, right? But from the other side, the SETA rod connector, the SETA rod will be here, right? In this area, and I would be here watching the machine. So we are seeing it from the other complete side. Here you have a hole, right? Where the SETA rod connects. Here on this area, the SETA rod connects. But between this area and the bed, right, that you will find here underneath, and it expands because it's a shape. Here there is a whole thing. There's a whole space. And I tried applying force as they recommend, applying force on top of the metal on the two sides and let someone screw the screws. Doesn't work. In my opinion, doesn't work. So what I do is, you will see that here I have some. The printers come with foam, a kind of plastic. You will hear it fall. Yeah. You will see that the machines come with this foam. Yeah. Totally useless, you say? No. Because I cut a strip here, like this, of this size, and I put it between the bed and this area. And that, if you apply it correctly and you create the correct size, will create distance applied evenly, because this will act. I don't know why it's not doing focus. Let's see. There. This plastic thing, this foam, will act as the spring, as here. So I found that whenever I'm calibrating the machines, I use this foam, and it almost applies the pressure evenly, which is great, because I found a way to, before that, I had a lot of issues with calibration. And with this, I have perfect calibration each time. In fact, it has happened that I haven't calibrated them ever since, which is great. Now, the other issue that I found is that between the machine, let's say this is the surface, right? You have the frontal LCD here to touch the machines. You have the USB here. I'm trying to show you some key marks so you understand my drawing, right? And you will have the LCD here. This is without the batt, right? You will have two screws here to put the batt on and screw them on top. The LCD, it's not like in previous generations. In previous generations, it came kind of protected with a glass. Now the LCD is bare. or at least in my experience, it's bare. So basically, if you scratch this surface, you're scratching the LCD, and that will bring issues with 3D printing, which I'm going to mention in a moment. But this here, what I do is, using this plastic here that I have remaining, that it was from the FEP, I cut it bigger than the LCD area, and I leave like a 1 centimeter extra. You will see that you have some kind of edge here, and then I apply tape on top of that edge, a very small one, like also 1-2 millimeters, no, centimeters. The same here, it's centimeters, not millimeters. And that basically gives me a protective layer on top of the LCD, that if the print fails, right? And let's say, for example, there is a very, let's simulate it with, here I have the brushes that my wife uses to paint. Let's say here you have a print, right? That it's printing on top of the LCD on a point of the LCD constantly, boom, 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 boom. And eventually, if you print on the same place, or if the print is too sharp, the LCD will break. Or the FEP will break, and that will leak resin. If the LCD cures resin on top of it, and it decides to break, it will break. It may happen that the resin doesn't make it break, and you just scrape it with a glass scraper, and that's it. But it happens that breaks points, pixels on the LCD. So if that's the case, the LCD, it's kind of dead in a sense, because it will start breaking from that point onwards. So with this, you avoid all that. It takes time when you have to set it up, of course, because you have to do it well. You have to do it properly. You have to do it that it doesn't have any wobbly, any wavy surface. I have some that have wavy surface, and they give mixed results. But if you put it plain, it will work excellently. So this will be everything regarding calibration. I think the last thing to remember is that when you apply this, it may happen that you don't apply it correctly, which has happened to me, and that will give you a difficult calibration, which you solve using the foam technique, right? Or you can just reapply this, which is very, very cheap. Maybe you can get like, I got like 20 pieces of this fake FEP for like 10 euros. And I have purchased it like 3 years ago, and I still have half the box. Let me check. I think I'm not missing anything. I like how when I explain things, pages just start filling. Right. So let's see. This one is already filled. So let's see. That's how I do calibration. I think it's a very easy process when you know how to do it. But you will encounter that most issues are not regarding calibration, but there are a lot that are regarding calibration, but we will tackle it in a moment. So I already spoke of how I protect the LCD, which leads us to cleanup, right? When you're working with 3D printing, when I am working with 3D printing, I like to be like a surgeon. You roll your sleeves up, you put your gloves, and now you walk like this. I can't show it to you, but you're not touching anything, and you touch with intention, right? Because what happens? I have seen people work, and this is something that I have highlighted a lot. I have seen people work, and they ask me, why are my machines all dirty? And it's because they don't understand that whenever they have oil, remember that resin is oil-based. Whenever they have oily hands, that oiliness is transported to everything. So whatever you touch, it becomes a hazard, because if you have your hand clean and you touch that surface, now you have oil in your hands. And it's not an oil that it's absorbed or dissolved or just evaporates. That oil stays forever in that surface. So what I do is, I will call it chuf chuf, right? Because it's It's the sound that it makes, and it's the way that I say it. But it's basically a sprinkler, right? But for me, it's like chuf chuf. It does that sound. So I have two chuf chufs with IPA, with isopropylic alcohol. So whenever I lift something or I touch something, I do this with my hands, and I do this to see the light shine on my hands. And whenever I see shininess, like some surface shining on my hands on both sides, I just go grab the chuf chuf and clean it. What happens if I have my whole hands covered in shininess? I grab a paper towel, I grab with that paper towel the chuf chuf, clean myself, sprinkle my whole hand, wash properly, and then start cleaning again. Do the same chuf chuf chuf, clean again, and then clean the chuf chuf, because it will get some of that oiliness. Um, Also keep in mind that whenever you do the chuf chuf, try to do it on a surface that the IPA falls into, so you can recoup that later, which I will explain in a second. So basically we're talking about hand sanitation here, but for 3D printing. Whenever I do 3D printing, I always do a butt clean. That means that without printing anything, the whole LCD turns off, and you can project a whole layer of UV light for 15 seconds. So whenever you remove the resin, you will have a small layer on top of the FEP that you can easily scrape. I do that all the times, because that saves me from having a small debris of support or stuff like that break the LCD, or break the FEP and then later break the LCD. So that way you are not only saving money, because you say, oh, but it's time consuming, it's you are wasting money with the IPA and all that stuff. Guys, when you have to wait for an LCD sent, and it sometimes takes 2 weeks, or they don't even have an LCD anymore, LCDs is better just to keep them as better as possible, as clean as possible. And these measurements have saved me, in the long run, thousands of dollars. I remember that whenever I had my first printers, I had several issues, and I had to buy several LCDs, and that amounted easily to $400, $500. It was painful. So also you're losing the possibility, income, profit. When you are not printing, you lose that, right? So it's always better to have the machines properly tuned, properly clean, and whenever the opportunity comes, you can react accordingly. So let's see, hand clean as a surgeon. So I have two types of gloves. I have one that I always use nitrile something. Nitrilo is in Spanish. This is in contrast with the normal gloves, which are like, I don't know how they are called, but they are the ones that comes with the printers. I don't use those because they can't be reused. They are for using and throwing away, because it's like the plastic from balloons. I don't like it. I don't like how it feels. They are very difficult to clean, like with the chuf chuf. So what I do is just I purchase a box of 100 gloves of nitrile nitrate of nitrile gloves. Generally come in blue or black, and those are very good because not only they can be cleaned easily, but they can be reused several times. In fact, I have used those gloves, just one pair, for months, and I don't throw them away, because I'm so good at cleaning at this point that I don't break them, I clean them. And since they are mate, you will notice the shininess very easily, right? So that's why I use those. But I have also a second pair of gloves. These I throw away. These are the gloves that, have you went into a butchery or a carniceria where they put these plastic gloves, and whenever they do something, they end up not they end up they assist a customer, they finish the order, and they just took and they throw away the gloves, and they put others new. They are very cheaply made. Plastic gloves are the ones that after COVID they give you to select the fruit. Those are the ones that I'm talking about. Those are the ones that I use for post-production, right? To deal with IPA, to put the hand inside the cleaner and to get back the pieces, to break supports, or whenever I have to do something messy, I use those. Because when you do the cleanup, it's when you have the whole glove covered in resin, it's very difficult to take it to a better state, right? To get it back in shape. So what I do is just I throw them away. The others that are very, very cheap, I just throw them away. So having said this, clean as a surgeon, um, I have lent my printing machines, and whenever I got them back, they were very dirty, right? And they are, you can't get them back in shape because of all the grime and all the cured resin that it has on top. So try to have your machines as clean as possible. This will be the things that you will be working with, and you need them to work properly. So if they are dirty, they can't work, and it will bring more problems. It will bring frustration that shouldn't be there in a hobby or in a job or in a project that should bring happiness, right? Um, Everything that I'm telling you in this video and that I will tell you in a moment, it's the result of years of frustration that I can now watch in awe and share with you all the things that I learned. Uh, so hopefully you find this very, very useful. Surfaces always clean. Whenever I use something or I put it on top of something, I just go and clean. You have to be kind of obsessive with this because you don't know one. For example, we had an issue once with someone working at our studio that brought a dirty hand, grabbed a hand knob, and after that we didn't realize that whenever we touched that hand knob, we started putting resin everywhere. And then since there was sunlight in those other areas, the resin cured on top of walls, furniture, items, technology. So try to be as surgical as possible with your cleanup. Of course, what I do, which makes this very, very easy, is that the post-production table is different from the printing table, even the areas that I work with. So the print tables are all covered not only in plastic, like I have a very thick layer of plastic that I purchased at the do-it-yourself store, but I also have this thick plastic here that you will see here moving. I have this thick plastic on top of the table, and that's just for the 3D printing table because I want to be able to keep that surface clean, or at least to tell me with the shininess that it's not clean, so I can go and clean it. The post-production table is very different. That is a very cheap table, no protection at all. I think the table, the cover, I don't know how it's called, the surface, costed like 10 euros, and that's it. It's the cheapest you can find because we knew that we were going to destroy it, basically. So that one we don't clean, simply because we know that whenever you clean it in the next use, it's already dirty, so it just keeps being dirty. So since it isn't an issue for us to have it dirty because you go there to do dirty stuff, you just keep it dirty and that's it. And when you are mindful, when you're being surgical, there is no issue with having dirty areas because you are not bringing that dirtiness to the clean areas. So separate tables. And the last one, this one I hate with all my heart. Have you noticed that the bats, right? You have here, you have the resin. Sorry about my cat, but she was crying outside that she wants to play with the ball because she's kind of a dog. She was raised with a dog, so she plays fetch. You have the resin here, which is not as wavy, but just to symbolize water, right? Something like this I can draw to save my life. So you have the resin here, and for some reason the companies thought it was intelligent to give us So I don't know where I was left because the video ran out of memory. But basically, we went back to we are being surgical, right? And these bats have this corner where they expect you to pour resin out, and they think, oh, it's going to fall like a waterfall. No, the the oiliness of the thing makes it go underneath the bat and also go underneath the FEP, which is a nightmare to clean and that you can never have clean because between the FEP and the parts that comprise the bat, there are inner areas, inner chambers, and whenever it gets inside the screws, impossible to clean. So how do I solve this? I use a syringe. I use like a 60 millimeters, 100 millimeters syringe, and I just suck the resin bit by bit. I think I do it with the thumb. I grab the syringe like this. I tilt the bat like this, and I pour it on top of a I don't know how it's called, this thing that comes with the print, with the box that the printer manufacturer sends you, like a filter, right? I use a filter, and I use a thing that I don't remember, that it's to concentrate the flow of the resin. These use the ones that you can interchange, the ones that are for coffee and stuff like that, because not only they are very cheap, but whenever this fills with debris, right, with supports and all that stuff from pouring, you throw it away and you change it, and that's it. When you use the metal filter, that thing will get grime and you can't remove it, and it's very small and it falls. And don't get the metal one, don't buy it, it's very expensive, it's useless. Buy a plastic normal one and buy the filters. Funnel, that's the word, funnel. So syringe, funnel, filter. So consistency is the name of the game. When you learn to do all these things that I mentioned and to be very surgical about the process, you will get good results. And whenever it's consistency in doing these things and in looking to get your craft better. Because when you look to get your craft better, it not only improves, but the way you do the things that you did previously do improves. Like, for example, I think this print, which is great, it looks fantastic, and this one is years apart, like 2 years apart. And of course, I like this more, but not because it looks better, but because I know all the information that this new one has, all the advancements that I did in order to be able to print something like this. Because this is very simple to print. This is not, right? This is have many parts, and it prints beautifully. And this one has some problem with lines and wobbliness, but still a cool print. See that even if you are not looking for, let's say, perfect, still you can get good prints. Printing in resin is magical as like that. So at some point you will hear my alarm. Don't get scared about it, because I will run out of memory and I have to keep recording. So from my map, we did this, and these are the fast area, the fast part. So let's tackle it. Right now we have just finished the second part of the explanation of the video. I think these are the concepts and my philosophy on how to do stuff, and I think that's very useful. Hopefully you find this useful. So now let's start with the troubleshooting. I think you have now knowledge on how to do how things are run in 3D printing. So let's see. I will just start tackling them because they are very unrelated in a sense, and you will have to encounter the issue for these things to make sense. So the first issue that I see people have is that not knowing where to start, what to print, or how to be new at 3D printing. So this is an issue that I see a lot of people that they want to have a business or they want to start this and that. Kind of cold, so I'm going to pull this. Pull this. We're not being surgical here, so I can have this down. Not knowing where to start, what to print, or how to be new. In order to be new at 3D printing, you have to get the machine and fail. That's the only path. And then you can rely on the community to ask for help, and you will improve super fast. With this video, I'm sure that you won't get as much failures as I did when I started. In fact, when I started, I bought a super expensive machine, like 1,500, something like that. Frozen Shuffle, something like that. Very expensive. It was a good machine, but then Elegu came up with a $300 machine, and I basically purchased that one and worked with that one. So buy not the cheapest, but there are very, very cheap options. In my opinion, Elegu, the best brand out there. I hope I get supported at some point with them. Talking about support, I used Resione resins because I thought they were the best, and now I can say gladly that I have been supported by them, and they gave me a lot of resin to play with. So all these projects that I'm doing are thanks to Resion. So know that I used their resin beforehand, and now I'm happy to say that they are supporting me. So thank you so much, Resion. Go and buy their resin. I use TOF 72 and TOF 74 B2 to print basically everything, and then you can use flexible resin that they are always coming up with new resins. I have to test the Resion, I don't know, something 39. That seems to be very good. I have it in store in my shop. So let's see how that works. So not knowing where to start, easy. Buy the machine, download something from Thingiverse, try to print it, and you will get good at it eventually. But don't waste resin. Like if something is not working, it's not because, oh, that time didn't work. No. If it didn't work, it is because of something. So that's when you will have to start iterating to see what's happening. You will have to know your machine. You will have to know how 3D printing works to solve it. 3D printing in resin is much easier than 3D printing in plastic. So I recommend it for new people to learn how to deal with all this stuff. That will be it. Just start. Get the printer, download something, buy any resin, do it. So the most common one that I received is prints not sticking to the bed, right? So you have the bed here, and whenever they finish, I don't know, 11, 12 prints, people say there is nothing. Absolutely, this would be texture, right? It has, depending on the brand, it has some texture. I have nothing but droplets, right, on my bed. Why? And whenever they go and do the tank clean, all the small things that they were printing are stuck to the FEP, right? At that point, you do the tank clean and just remove it. It's very, very easy. Don't try to remove each single specific thing. Do a tank clean, remove them all in one go. This happens because of calibration. Simple. You did not calibrate properly, calibrate again. All the slicers come with a basic printing profile that generally works for most printers, so I would discard that. This is just a problem with calibration. It may happen that this goes to the second problem. It may happen that you have some areas, right, that you have a print that half-assed appeared, right? You had like a silhouette, right? Or at least the raft or the supports are stuck to the table, but then it fell. So this happens because of bad calibration, right? And other issues. This, if you have one here, but nothing here, and you put to print, it's bad calibration. If you have all the things in your bed, right? All the shapes and the raft is just, for example, let's say that you have a ball and you have all the supports. Each support will have like a small cone on the bottom. A raft, what it does, it calculates the shape of your item, and depending on the slider that you chose, it will create a small platform to unify all the supports. So if any support fails, it will have the others to support the print on. I recommend the raft. You will have to tweak it for what you're using it, but generally I strongly recommend it. So if, for example, all your items have rafts, right? And let's say that this area didn't print, it has nothing. That's because of calibration. But if all the rafts are on the bed, but no supports, or there are empty supports, right? It goes like this. You say, oh, the supports came out amazingly. The raft is perfectly stuck to the bed, but there is no bow, there is no geometry. It means that the pull up, right, when the bed separates from the FEP, it's too fast. Too fast means too strong also, because there are a lot of things happening. Like, not only you have the velocity, the velocity in which the bed goes up, but also you have the distance it goes up, and they are kind of related in a sense that if you tweak the velocity, you will have to add more um, going up or down, because this one of these, I think it's this one, the velocity, it's measured in minutes, so it has to do with time rather than distance. So for example, if you half this time of going up of peel force, you will have to double the distance it goes up. But this solved most of my issues. This is a very important thing. But yeah, you will have this issue. This thing solves most of the stuff. And then you have the other thing, that if there is some parts here that are not sticking, it may be how to spot it. Let's say that you have the bed here. Sorry, but I'm jumping between things to see how I can better explain it. If you have the bed and you have, for example, here, right, you have a raft here, and we're supposed to have a raft here, but it's not here. If you're printing everything perfectly on the corners, but you're not printing perfectly on the center, it means that it's not calibration, because the calibration, you can measure it by these 4 points, remember? But if it's in the center, it's a problem of the FEP, and not the FEP, that the FEP is broken or that it needs changes, but it's a problem here. It's because the peel force, right, whenever the bed is peeling from the FEP will do this, right? It will stay peeled, it will stay stuck to the bed, and this will be the walls of the bat, right? This is the FEP, that whenever this goes up enough, it will just, and it will release the suction, it releases the force, and the small layers will be kept on the bed. So whenever you have a problem in the center, is generally suction or peel force. This is solved by this, and by upping the bottom layers. When we get into how slicers work, you will see what bottom layers are, but basically you can decide how much bottom layers you are printing, and then the rest of the layers. The bottom layers are generally configured as 6. They are the ones that burn into the bed, and then the rest are the normal layers. In order to have perfect prints, I use like 70 bottom layers with 30 transition layers into normal layers, and this has solved most of my issues. Remember that big machines have bigger problems, and have problems that the smaller machines don't have. Why we are printing in bigger machines? Because we want to print a lot of parts, and we want to print big parts, right? I'm printing like a whole ship, so I need to print big. It's a good thing, because when you are going big, you will get bigger problems, but if you solve bigger problems, smaller things will not look as a problem, or will get solved in the meantime. So I'm going to change the memory of the camera and come back. So where we are at, this very important, lift very low, lift very high, bottom layers a lot, and I cure each one for 60 seconds. And then my normal layer is the normal 2.5 seconds. In fact, I'm going back to the shop after recording this video, and if everything printed beautifully, because I'm always learning even after 6 years, I will just cut down this by 5 seconds, and this I will put it to 2.3 and see if I can start cutting time on this area, but not on this, because this is what making it work. properly, right? I'm keeping the 70 base layer and I'm keeping this, because this ensures that the peel force of the whole surface doesn't tear down the supports from the raft. The 60 seconds help to keep the raft on top of the bed, and this just makes it print well. If I go lower than this and the detail starts not getting in there, I know that this will start failing when the model falls from the supports. I know that's when I have to dial it back. This I will know when these things start falling from the bed. So I'm sure that I will be able to lower this to 40 or 35, and this 2 second I will be happy. And maybe this is all this figure. I think the highest part is the swords, right? Yeah, the swords. It was around 8 hours to print, and maybe we can cut times to 6 hours, something like that. Why so high? Well, I have seen profiles that can do this print in 2 hours. In fact, I think I printed one of these that it will be around 15 hours. I printed it in like 4, and you say, wow, that's crazy, blah, blah, blah. But you have to have the machine and the resin set up for that, because that's fast printing, and fast printing, I think it has faster curing. I don't have that. I may need to get that. At this moment, I don't need fast. I need consistent, which is what the general people will need. So let's see, which is the next topic. Common one, print not sticking to table, curing time or leveling. Yeah, so from this point onwards, the calibration is no longer an issue. If you have a perfect calibration, the rest of the things is just tweaking your files. Also, this will have to do a lot with temperature. People believe temperature is such a big deal on your prints. It's not so much. You have to keep that room between, not between, but from 20 upwards. Grades centigrades, I don't know how it's called, grados centígrados, right? So 20 upwards. 25, if you are using heating system, I would say it's the limit, because remember that you have to get in the printing room, and 25 starts to get pretty steamy, pretty stuffy in there. So I would say around, if you can choose, 22 or 23 grados centígrados would be best. Lower than that, which is the problem? The printer, not the printer, the resin is, since it's an oil, it gets viscous, right? It starts getting slimy. So in order for the printer to run well, you have to have it as liquid as possible. So what people do in order to avoid these kind of things is to heat it with hot water before, or with a heat machine. But this brings a few issues. If the hot water or the heat machine is very hot, the resin may start getting cured inside the bottle, and that only serves you for the first layers, right? But then the whole thing will be cold, because it will be on the printer and not inside hot water, stuff like that. It's true that the printer exudes this heat, produces this heat, and also that you can buy heaters for inside the printer. Either they're selling one at 100 euros, that is kind of a USB heater that connects to the side of the printer, which people have good results with, or there is one that you can buy a LCD or something like that heat strip that goes around the bat, right? This is a bat. It goes around the bat and connects to the USB. But being honest, it's better to just have a heating place, or just to put a cardboard box on top of the printers so the heat stays inside, and to have the resins in some place that is heated, right? So the resin is always liquid. In fact, I received a new type of resin to test it out recently, and it came in a block inside the bottle. And I called the manufacturer and I was like, what is this? And he told me, have you heated first? No. Well, heat it. I heated it, and once I heated it, it never came back to the block form. So it may be that they just pour it inside, or whenever they travels, it gets very cold and it stays in that thing whenever they make it vacuum sealed. I don't know. just information that I think it's cool to know, and that informs decisions that you will take. So this issue, very, very easy, very, very fast. This is support related. If the model is falling from the supports, you are either having a lower curing time, the support of your tip is very thin, so make it thicker, or you have a lot of suction. If the suction works well and you don't want to change the supports, try upping this. But I don't mean by little, I mean by a lot. Like, for example, let's say you have it at 2.3, right? Up it to 3, to 4 if you want. If this makes it work, it means that the tip is very small. If this makes it work with just a small change like 2.4, it means that this was low, and this was okay. If you use bigger tips, you can use less time here, but if you use smaller tips, you have to use more time here. If you find a balance between this, great. But the most important thing is that you have to have as less support marks as possible. Because when you have the surface, and you have this here, I'm drawing on a monitor. I have the monitor there, and I'm watching the monitor. I have some slight delay. So this would be the support, right? The support tip. So you want this to make it as small as possible, because later you will have to sand this. So if you can avoid having these kind of issues, this would be solved by having a thin tip and higher times, right? Once this is very small and you can lower the times, in that direction, you can lower the times, better. That would be the best result. Why upping the times work? Because the more cure time it has, the more over-cured resin deposits around this, right? Around the support, and it creates a bigger surface of contact. It's very small, but it's noticeable. What's the issue with bigger times? You don't get as crisp of a print, right? All this, let's see if I can make it notice you. But see that all the details that I have here, if I had higher curing times, they won't be noticeable, because the resin would start to clump together, and that's it. The higher you go, the less detail you have. In fact, if you, for example, are a madman like me and use these times and this amount of layers, bottom layers, you will notice that the raft, right? The raft that supports our support, supports our support, will start getting kind of not delaminated, but you will see that whenever, I don't know if you guys had fungus on the nails, I had some, and the nail starts delaminating. It's still there and it's still strong, but it delaminates. This will happen the same. It won't delaminate in a way that will remove it from the bed, but it will delaminate in a way that it says you are over curing me. So I know that at this time I'm over curing it, so I have to go down. It's a must. So another issue that I think that I already explained, but I think it's very important, is that people get perfect calibration and the supports fall from the rafts, right? This is the bed, and you have the rafts, and the raft printed perfectly. They are perfectly adhered to the bed, but there are no supports. From one point onwards, there are no supports on the raft. And it can happen not in all the printer, but just in areas, right? You have patches where the supports fall, like they are stripped down from the raft. So this is an issue of layer suction. Not layer suction, but the way that the bed goes up and down. So if you go slow and you go up, this solves. I'm currently going as slow as 10 millimeters per minute. That's how slow I'm going for 70 layers. So I have just 1 hour or of 70 layers just to have the base correctly. Once that's done, it's solved. Basically, you change this and this gets solved. This was a very hard issue because I had areas that the support stuck to the raft, but then the other half didn't print properly, and it was a headache because I didn't know how to solve it. People told me, no, it's calibration. You are pressing the LCD too much. Sorry, the bed too much against the LCD, and I'm like, oh no, I have been doing this thing that I'm trying to press the bed without any paper against the LCD. They are right, and it didn't solve it. It was this. This is the grail of consistent 3D printing. Then you get wobbly 3D printing. 3D printing, it's either the set rod, it's wobbly, which you will notice if you are looking at it straight, and it in some areas it curves like this, right? You will notice it. People say that it's this issue, and I haven't found it in resin. I have found it in FDM. I think it's a vice that to look for this thing, that it's brought from FDM. I have never encountered it. If the print is wobbly, generally, like you will see that it has like a wavy texture. It's either over curing, or that the printer doesn't have the four corners. It's not. It kind of tilts. The printer itself wobbles. So textured prints, they have some kind of texture. That's a problem with FEP, or LCD is having issues. We have to talk about the LCD because I have some comments about that. But if the LCD is very old, you will start getting like gradients of black, which means that the LCD can't turn on and off in that area, and it feels like liquid. It's not the same as the LCD breaking, but it feels like it's like a spillage that it's getting to all the LCD. That's when you have to retire that LCD and get a new one. But texture 3D prints can be a faulty LCD that it's very slowly dying, or a bad FEP. Generally, if you and overcuring also, if you solve these issues, these other issues like the zeta rod that it's curved, the texturing and all that stuff, it's very evident if it's something else. But if you nail this, I promise you that you won't have the other issues. At least not normally. You won't have to find those issues. So black spots on the LCD, that's a whole new topic. Let's jump into this one. Hollow prints delayered. So let's grab a new paper for this one. These are very small prints, right? These are not hollow. In order to save resin, you can make parts hollow. Let's say we have the ball, it's a perfect example. You can make it hollow, right? And you can do it either on the program that you use, or Chitubox or Liche, that are the slicers. You do them hollow to save on resin, because if not, printing something like this, it will be very, it will have a lot of weight, and it will be very, very expensive. As you see, it's hollow inside there. I don't see if, well, it's very dark. But as you can see, it's hollow. You can put your prints in there. So basically, you do it to save on material, and also it's sometimes when you're printing something big, making it hollow may help with printing it. Like you may be able to give support to the piece on the inner side, so it's easier to build a wall, for example, if it's in this direction. Also, I haven't talked about model orientation. Always try not printing it parallel to the bed. The bed will be here. Don't print it parallel, printing at a slight angle, and always as vertical as possible, because you want parts to have, since this is, let's say, this sword here, that as you can see, I do this and it doesn't break. You have the sword. You don't want to have parallel to the bed, the layers, because this is built in layers. You don't want it to have like this, because this is very brittle and it works and it breaks. If you print it like this, right, vertical, it means that you're printing it parallel to the bed. This is the bed. you're printing the sword parallel, so there, whatever is pointing to the bed will lose detail. So you want the areas that lose detail to be the ones that people don't generally see, that in this case would be this. But even in that situation, let's see if I can focus, you can see that it has some detail, right? So this, no, because it will be super strong, but it will lose detail all over this area. The best bet would be to print it slightly curved, right? That it's focus there. Slightly curved, which is what I did, which will make the layers like this, and it will less likely to break. Also, the material that you print in is very important. TOF 72, sorry, TOF 74 B2. It's very, very flexible. That's why I use it for prints. Let's see if this one works as intended. No, this one doesn't go out. But yeah, the idea is that you can remove the parts and they still work and they pop in, right? That's very cool. There you go. You can hear the pop. Let's see if, yeah. So Resione, great brand, great resins. So let's go back to hollowing. If you just hollow them, you will have new issues, which are solved easily. Make a hole. If you make a hole, resin won't be trapped inside. My God, the focus is killing me today. Yeah, that's it. If you make a hole, the resin won't be trapped inside, and you won't have resin pockets. This resin then later breaks the print and comes out. So you have to avoid having pockets. Most of my time sculpting this figure was trying to remove as much pockets inside the belt of this character. You can see that it's a very intricate part, right? But there are no pockets, right? Here you can see the holes. This one doesn't have them because the parts are completely full. What you do with removing pockets, it's making the geometry watertight, so no water can get. It's a concept, right? No, there are no pockets, no water can get into the crevices and cause this destruction. This is very, very important, because if you send a client this and it breaks, it will not only break and destroy the work that they did on it, but it will also damage the whole piece. It can damage furniture, can damage other collection stuff. So this is a big problem to avoid. Just create a hole. Sometimes it's not possible to create a hole, so you will have to find a way to make the hollowing process differently. I generally do a fast hollow on Chitubox, and I bring the hollow geometry into ZBrush, and I do the cleanup of the hollowing there and creates the holes there whenever I see it's appropriate. So hollowing brings new issues, which are prints delaminating. If you have a very big print, let's say something like this, and I'm emphasizing that it's big because I'm using half the paper, let's say that this is the bed, you will have all your small supports, right? And let's say that I just stop the print and the printer stops, the bed goes up, and you see that this goes like this, and oh, it's printing beautifully. But this has a huge suction force on the FEP. These big things that that have like a big ring create a whole force of suction on the FEP, and it's very, very difficult for the thing to print. So what you have to do is to fill the thing with holes, which can be later patched. If this is a big thing, fill it with holes, because it will delaminate and it will not print, and you will waste not only hours but materials into something that won't print. The way to solve it is add a lot of holes, not everywhere, but this is to release the tension of that suction, because the longer it goes, the suction it goes, the more force it does, and it can even break the printer. So it's better to avoid that. And also this solves another question, another issue, which is whenever there is too much suction in the layers, it starts getting textured outside. on the outer area. So the holes erase that also. So whenever you are printing with hollowed prints, print with a lot of holes. The outside problem of the texturing is called frosted texture. I haven't found many people that explain how to solve it, but this is I had like a print, I had to print like a big thing, like 15 hours of printing, and I had that issue. And I said, oh, I need to sand this, that, it delaminated and all that stuff. No, I printed it again, but adding holes, and it fixed the issue, and I just had to cover up the holes. That was great, really. So I think the last topic that we have is the LCD, and give me a second that I'll stop the recording and get back to it in a second. So let's see where we are at. This is the last point that we have, and then you're free to go, basically. Black spots on LCD, random old. Well, let's see all the things that have happened to an LCD. As you remember, LCD is the screen that is in the middle of the FEP, the bat, and the UV light, and the LCD turns on and off by pixel depending on the images that we created in the slicer, right? The slicer just grabs a model and separates it in black and white layers, and that black and white layers just tell the LCD where to turn on and where to turn off, and based on that it starts building like an MRI. It builds a 3D print of the model that we had. When do the problems arise? When we have a faulty LCD, and that may happen from the factory. I have never had that issue, that the LCD is faulty. And if that's the issue, whenever you purchase a machine, you have you're protected, you're insured. So they send you a new LCD. So the issues that I find is, first one, you break it with resin. A drop falls on top of the LCD when you are doing cleanup. You put the bat on top, you start curing stuff on top of that droplet, it gets hard, and whenever the bed goes and applies pressure on that droplet, it breaks the LCD, it cracks it, that's it. Whenever an LCD is cracked like a spider web, no turning back. Everything that you print will come out with random textures. You can still use it, not recommended, because you may get some cool effects, but you won't get consistent printers. I will still try it though. It may bring a cool result while you wait for the new one. This is a human error, basically. It's avoidable if you are surgically clean. The second one, it may happen that you did nothing wrong, but sometimes the 3D printers drop droplets of resin on the sides of the machine, which is something that I generally comment that you should clean up. You should check your machine, not daily, but weekly, to see where it is spilling resin. It may happen that even with the protection that I recommended, that some liquid falls in between, right, the LCD and the protection, and it cures on top of the LCD, and that just kills the pixels, and you may have areas that this happened on top of your LCD that you can't use. But that doesn't mean it will spread like the last example that I have. It will mean that you will have just dead pixels, and you have to plan your printing around those dead pixels. This is easily avoidable if you apply not only a bigger protection area, but also a bigger even tape in the middle. It can still happen, right? It can still happen. Sometimes it's by pressure of the LCD, sometimes it's because just that area of the LCD but was bad quality. Doesn't matter. If it happens, you just avoid that area and print on the rest. It won't cover the rest of the LCD eventually. I have one LCD. I have 3 printers that are having problems now, and I'm not changing the LCD. One has this issue. In fact, they are in order. One of these is having this issue, but on the corner, so it's just a bit of it, and so I don't print there, and I print on the rest, and everything's good. This one has the same issue. I have one that has like a thing here and a thing here, so I print on the rest of the thing, and it prints beautifully. And then you have the third example, and I think this one is kind of terminal for the LCD. The LCD randomly starts getting spots that make no sense, spots small, big, whatever, and they start growing. And they not only start growing, but they have different gradients of translucency. So you will notice that there are areas of the spot that are darker, some are lighter, some are darker. That means that the LCD reached they are old basically, and each LCD lasts, the current ones last for 300 hours, right? If it breaks before these 300 hours, they should supply a new one, but basically when the LCD is doing this, that's it, get a new one. This is happening in one of the machines, and I'm still using it because I noticed that from the bed this area is having no issues. This one is slowly like dying. It's like it's perishing slowly, but this area has no issues. What happens with this, right? That doesn't happen in these two first. This one, if this area, right, that it's having these issues, touches part of the model, it will drag the model to stay cured to the FEP. So for example, I tried printing something here, something very big, something here, and something here. Since it had issues here, the model basically at one point, when it started printing the model, like it printed the supports, everything was great, but when it started printing the model and it touched this area, it dragged the model to the bottom and it stayed there and it didn't print. This one printed beautifully. So you can use still the old ones because they still work, but they will slowly perish. They are they are dying. So basically order a new one. So almost a week has passed since I recorded the previous part of the video, and as I mentioned in the intro, or in the pre-intro, a lot of things happened. So let's go over them now. Which was the problem that I started happening? I had to have the bottom exposure, bottom exposure super up, right? We're talking 60 to 70 seconds, and 60-70 seconds, basically you wouldn't be able to remove or scrape the parts from the bed, and I could. So that's a bad sign. Then I either lowered or moved higher the normal cure time of the layers, right? And there wasn't kind of any change. I was playing with that and it didn't work. Then the other thing that I said that you could play with was the velocity, right? And either the speed of how it goes up and down, both for the bottom layers and for the normal layers, and the height, right? Let's see if I know how to write it. I think it's like that. Height, how tall and how low it goes in this speed when moving up and down, when curing and letting the resin in the vat move itself, right? When it goes up and down, it not only mixes the resin a bit, but also lets the resin go underneath, right? Underneath the bed, like this, right? It opens up, so all the resin can go down, and when the next layer goes down, it can cure again. So I was having, this didn't work, changing these things. I knew that the supports were good. Yes, another thing was the supports. I knew that they were good because I tried printing them in different parts of the bed, and sometimes they printed, sometimes they don't. But when they printed perfectly, and when they don't, they either didn't stick to the printing bed, or they stuck and they left the raft, right? Like the shape of the object that it was trying to print. What else? Well, then you have the transition layers, and the transition layers and the amount of bottom layers. Let's abbreviate it like that. And I changed them up, down, didn't work. Let's focus, camera, focus, here. Things kind of work sometimes, didn't work later. If they were working previously, I was trying out profiles that worked that later didn't work. So okay, as said, let's go back to basics. I have this rule that whenever I'm overcomplicating things, I always go back to the beginning, but I'm wiser, so I kind of know better to where to go. So the first point is calibration and the basic profile that comes with Chitubox. Yeah, so we go back to basics, which is something I recommend when things are getting tough. Back to basics, so calibration and the basic profile for your printer. At this point, when everything this was failing, I stopped trying out my 3 printers at the same time and just stuck to one. And I chose one part of the bed to print in, right? I had like the bed, and I chose like this half to print stuff in. And when they were good here, I started moving in this direction. So what I found, which is very important, is that my 3 printers, my Saturn 3 Ultra, which I'm using to print slow, not fast, slow, Saturn 3 Ultra, all have the same problem, which is surprising to me. And that reminded me of something. All had the same problem. When I was calibrating them, didn't matter the technique. If I used the Elegoo technique, the other brand's technique, the putting 2 papers, the putting 4 papers in different corners, nothing worked. Because the problem is that this, and this corner can be adjusted to the same height, but this one is always looser. Let that sink in. In the 3 printers, this corner or one of the corners in the same printers, they were always loose. There was no way to calibrate it properly. So which was the end result? Everything printed perfectly here, and when they arrived to this area, they started peeling from the bed, right? So applying the concepts that we learned, I'm going to leave this here. Applying the concepts that we learned, we know that when you up the exposure time, the layers are thicker, right? So if the problem that I'm having is that in one specific corner of the bed, this one, is not touching properly the LCD, and in the others, it's closer, right? The distance is different. So how do I do to match the distances? I up the cure time, especially the bottom layers, right? Because the problem that I'm having is that the prints are peeling from this area in that direction. So what I do is I up in this direction, not in this direction, but I up the bottom layers. So I think I had them for, I don't know, the base profile had it at 45 seconds, and I upped them to 60. Just that, basic profile. And it worked. it worked. It printed beautifully. It didn't print perfect, because if this now is touching this, it's overcured because it had enough thickness already to print. So since it's overcured, when layers are overcured, they start peeling like this, right? If you have something like this, like they start doing this bread effect, they are peeling because of overcuring. So at this point, I was very happy with this, right? But still, I wanted perfect, consistent prints. And also, I wanted to be able to come here and tell you guys, yeah, I was able to fix it. I was able to manage it, everything perfectly, and I come here to let you know how to print in big printers, which is a challenge, as I said in the beginning of the video. Small printers, easy. It has its problems, but bigger printers, always difficult. Always you have to do something. So all this situation of the three printers having the same issue in the same area means that we have to remind ourselves that these printers come from a factory. And although they look incredible and in most cases they work, they have problems that come from the factory, and that you have to factor in those problems when testing them out. So now that we know all these theoretical concepts, we can diagnose the problems that we are having. And I'm able to tell you this because I learned everything from like the Liche guy from YouTube. I have watched like 20 videos of him and took notes and tried stuff, and that shit works, man. That shit works. So here we are again. I was reaching, before all these problems that I have, I was reaching a 95% of accuracy. I had some issues sometimes, but I was happy. I could print, nothing deformed. But then I went like to 40, right? Just a part of the bed worked, and not even that. So as you can imagine, I was not only pretty pissed, but pretty tired, because you have to go clean, bat clean and everything, and then pour the resin again and wait, and all the expectation that comes, right? You will face it when you're troubleshooting. And I heard a guy, a Chinese guy, which had a super different approach to printing to what I'm used to. And he explained in a 6-minute video the concept of light of delay. I'm going to note it here, light of delay. So this concept, the the Liche guy mentioned it several times, and he told me in the video that most of the issues are either calibration, curing times, speed and height. And I was like, well, but I already tried this and it still doesn't work. And he mentioned later light of delay. And I was stunned, because in all my years of printing, I have never tweaked this. I always left it as it came from the factory, right? From the base settings. And I was like, yeah, let's give it a go. I don't have anything else to try, and I still have to produce everything. So let's try it. So I can't stress this enough. It changed everything. So what the fuck is light of delay? Just one setting that can fix everything? Yes. Yes, this setting can fix everything. Do you remember here when I mentioned that you need the resin to go under the printing bed and just lay there, so the resin is even and is not moving when the light cures, and it cures into the bed? This is the setting that makes that possible. So most of you won't see it at first, because when you turn Chitubox on, it's like in a different mode. you will see that I have it on the left bottom corner, and you will see that I have 3 values. So I changed the mode to light of delay, and then I set the light of delay of the normal layer, light of delay of the normal layer to 2 seconds, and bottom, right, the difference, bottom, the first ones, light of delay to 70 seconds. And you say, it's a lot. In fact, you will end up having more seconds in your light of delay than in your bottom layers, that generally it's 40 seconds. Yes. Yes, I'm going to have more light of delay than actual bottom cure layer time. Why? Because it works. Use this, everything changed, everything worked. In fact, it worked so well that now I can print faster. I'm testing how fast I can print, and I can lower the cure time of the bottom layer lower. I just can lower it. And I'm testing how low I can go. Here it would be a good time to show you which are my current times. I'll just paste them and show you. It will be a few seconds. Let's save Ado their magic. You can pause the video. But yeah, basically, why does this happen? Because this is giving time. That's the important part, because you have to understand why it happens. This, right, light of delay, how much seconds it takes from when the bed goes up, down, and waits until the LCD turns on again. That's what this is. So that lets the resin go underneath the bed again, and it stays there, and it's not moving. And there's no pressure. There's an even pressure in everything. So now I'm getting all the base over cured, right? Not only the left corner that we have here, but everything is over cured. So I'm just slowly going down and seeing what sticks. And when I start having problems again, I know that I have to go back to the previous profile. So I hope that I stressed how good this is. In fact, I suggest that whenever you get a new printer, just test calibration and light of delay, amp it up, and see how it is. And I'm sure that it will work, because I'm still using the normal basic profile with these changes, with the bottom layers, with the calibration, and with the light of delay. And I'm actually reverting back the bottom layers, right, to the normal C, and even lower if I can. I'm going to try lower. So why this is huge? Because mainly you're not wasting resin or time, and expectation, because your energy is also a resource. So if you're expecting it to work and it doesn't, you will get sad, you will harbor negative energy, and you will get tired. And when you're tired, you are not happy, and when you're not happy, the energy doesn't flow. So that's an important thing to consider in all these scenarios. So we are watching this video to understand how make this thing work, right? We are learning this, so we are autonomous, and we can help people, and we can understand how to make it work. So that's the main thing for life being easy, right? Being easy. Then using resources, well, I didn't want to write a lot. You are wasting resin, you're wasting electricity, you're wasting time, you're wasting everything. So when something works well, it's productive, right? So it's good. We want that. We want things to work. So that's why we are doing all this. We can plan ahead. And that recharges us, because we can plan. It's not like we are always sabotaging ourselves, right? And since we can plan, we can do. Now that I know that my printers work, I can just relax and print, and that's it. And I know when I go there, they will have print, and I can say, okay, I go at this time, I do the post-production for 2 hours, and they go back home, and then I go in 9 hours, and they are printed. yeah, so let's see how much time we have left. So we have 8 minutes. So why is important too? Because with all these failures, we were burning LCD, right? With longer bottom exposure, you burn the LCD because you have to have it on for more time, and you know that the LCD lasts for around 3,000 hours. So when you have it like 1 hour extra each print just to do the bottom layers, that adds up, right? That adds up. So the LCD lasts longer, so you can take better care of your machine. And when the prints go well, you save time because you don't have to bat clean. You can just suck all the resin and just put to print again, pour the resin and put to print again. That not only saves on LCD bat cleaning, but also when the print goes well, it saves you from a broken FEP, which is great because in the long run you save more money, you save time in changing it. It's all a hassle, right, if it goes wrong. Since I have 3 printers, right, the Saturn 3 Ultra, Saturn 3, and the Anycubic M7 Pro, something like that, the big one that it's the equivalent to Saturn 3. And then I have others, but these ones are the same size, and they all print at different times with the same settings. The Ultra, right, Saturn 3 Ultra, printed at 9 hours 40 minutes. The Saturn 3 no Ultra, 8 hours 33 minutes, and the Anycubic printed at 6 hours. This don't take it into account because the print failed at one point because of calibration. I'm not being able to calibrate it properly, so I'll let you know about that. So I think it ended early, so this is not something that we are taking into consideration. So I'm printing the GAL with my current settings, which are slow. I'm trying to make them faster. I'm sure that I can get it to 4 to 5 hours, right? 5 hours, but yeah, it's around 10 hours. So I post-produce at 10 a.m. and I have to go around 8 p.m. and put to print again. So I think that's all, guys. I say that's all like it was not only an easy watch, but also light on content, right? This is very, very cool stuff. I'm very happy about this, not only because it works, but also because I can provide a video in which it helps you solve it. Of course, I'm sure that this is not the best way to relay the information. I know that I'm just expressing myself, and hopefully you like this type of videos because I not only find them entertaining to me to explain you, like if you were here with me, right, in this chair, but also it's fantastic for me to know that I may be helping someone. Prints are going fantastic. We have already posted our GAL at Planetary Dog Toys. 1, 2, 3. Planetary Dog Toys, toys.com. The file is already online. You can get not only the file, but you can also get the print, right? I don't know if you have watched all these videos, if you are interested in the print, I'm sure you want the file. Important, the file, it's 8 euros right now because of the release. Once we release the next character, the 8 euros are gone and it will be 16 euros. So get it while it's cheap. This is one of the videos that I need to record to explain all this stuff. This is basically a troubleshooting video on what is 3D printing, and then I'll basically explain my whole process. This is kind of a course, right, on how to 3D print, because guys, I want you to give you all, and I want you to give you the best. So hopefully you like it, right? You like it, you learn, and you're happy, and you enjoy our stuff, and yeah, that's it. Until next one. Bye-bye.